A kernel module is a piece of software that adds functionality to an operating system's kernel without requiring the system to be restarted. The kernel is the core part of the operating system, the layer that sits between hardware and software. It handles essential tasks such as managing memory, running processes, and controlling hardware. A kernel module is like a plug-in for this core system. It lets the kernel gain new abilities on demand. Understanding the kernel to understand kernel modules, it helps to know what the kernel does. When you open a program, save a file, play music, or connect to Wi-Fi, the kernel coordinates all of these actions. It ensures that programs do not interfere with each other, that hardware is used safely, and that your system runs smoothly. But operating systems need to work on many different computers, each with different hardware devices. It is not practical for every kernel to include built-in support for every possible device or feature. That would make the kernel extremely large and slow. Instead, kernels are designed to be modular, meaning extra features can be added or removed when needed. This is where kernel modules come in. What a kernel module does a kernel module add specific capabilities to the kernel? Common examples include device drivers. These are modules that allow the system to interact with hardware such as graphics cards, printers, sound cards, network cards, and USB devices. File system support. If you want your computer to read a new type of file system, this support often comes through a module. Networking features, firewalls, VPN support, and routing algorithms can be added through kernel modules. The key idea is that the system can load or unload these modules while running. There is no need to reboot the computer. This makes kernels more flexible and adaptable. A real-life analogy, think of the kernel like the engine of a car. Kernel modules are like detachable upgrades to that engine, such as a new sensor, turbocharger, or performance chip. You don't replace the entire engine. You just add or remove the component that provides the extra functionality. The engine remains running, and the upgrade simply plugs in. Why kernel modules are useful? Efficiency. The kernel only includes what is needed. This keeps it fast and lightweight. Flexibility. Modules can be loaded and unloaded as needed. You can add device support on the fly. Easy maintenance. Developers can fix or update a specific module without replacing or rebuilding the entire kernel. Hardware compatibility. If you plug in a new device, the correct module can be loaded automatically to support it. System stability. While updating, many improvements can happen without rebooting the system, which is especially important for servers. How modules work behind the scenes. Kernel modules live outside the main kernel but run in kernel space when they are loaded. This means they have full access to system resources and hardware, just like the kernel itself. Because of that, they must be written carefully. Bugs in kernel modules can cause crashes or security vulnerabilities. When a module is needed, the kernel loads it into memory and links it to the rest of the kernel. When it's no longer needed, it can be removed to free memory. Typical lifecycle. Module is compiled. User or system tools request the module. Kernel loads it and integrates it. Module executes, while active module can later be unloaded if not needed anymore. Automatic versus manual loading. Many systems automatically load modules when hardware is detected. For example, plugging in a USB keyboard prompts the kernel to load the USB input driver module. But system administrators can also manually load or unload modules. This is common in advanced systems like servers or robotics platforms. Kernel modules in Linux. Linux is famous for its modular kernel. Most device drivers are distributed as modules. System commands like lsmod lists currently loaded modules. Insmod installs a module. Remod removes a module. Modprobe loads modules intelligently. These tools provide direct control over kernel behavior. The same concept exists in other operating systems too, such as Windows and FreeBSD, though Linux is the most widely known example. Security considerations. Kernel modules run with high privileges. Because of this, a malicious module can take full control of a system. A buggy module can crash the system or corrupt memory. For that reason, many production systems restrict who is allowed to load modules. Some systems even lock the kernel so no new modules can be added. Where kernel modules are used. Area purpose operating systems, adding hardware and network support. Cloud servers, live patching and performance tuning without downtime. Embedded devices, keeping firmware small while adding only needed drivers. Cybersecurity, firewalls, monitoring. Kernel-level protection, scientific, computing, high-speed networking, and computing accelerators. In summary, a kernel module is a plugin that extends the functionality of an operating system's kernel. It allows the system to support new hardware, file systems, networking features, or security tools without restarting the computer or rebuilding the kernel. Kernel modules make operating systems flexible, customizable, and efficient. Put simply, a kernel module is like adding a new tool to the operating system's toolbox without replacing the toolbox itself.